Welcome to my video module on the overall structure of DOE. It seems rather arbitrary where we're learning about factorials and blocking and then moving on to 2 to the k and now model reduction. And as we're getting into some of the more technical aspects, I thought I'd give a broader idea of where we're going and why. So back in the day, this idea of a concept map is what I have before you, where Novak did some work on trying to understand how people learn. And what he found is that people don't learn by memorizing things, but rather by making connections. And so what he suggested is that we find a way to graphically represent that. And that's what I've done here. If you remember, in pink, these are the prerequisites: statistics, probability. This is what we really focused on. And what we found is that statistics, it provides meaning and context for things like sum of squares, mean, t-test, F distribution, all these, Z distribution, all these ideas. And then we use those to explore ANOVA. And you can see that each of these, that our knowledge base is building. And so we learned about ANOVA initially. We had one way, and then we looked at multiple predictor variables. We've also seen times when we've used a regression equation to represent the modeling that we're doing. Well, this is based on another idea or another field of regression, which we'll get to later in the semester. And this allowed us to intelligently look at DOE, which is based on our 3 pillars of replication, blocking, and randomization. All this, if you recall, is rooted in agriculture, which then these practices became really prevalent during the Industrial Revolution. Next, we learned blocking as a tool which then guided us to factorials, seeing all multiple levels of treatments. In the center of this is model adequacy. Remember our 4 and 1 plots. Do we have a normal distributions? Are they randomly distributed? Are they independent? And also interactions. This was something that many of our ANOVA terms we missed, and we were able to later identify them by, say, using Fisher or Tukey. And then finally, I shouldn't say finally, the next place the factorial went was 2 to the k, and we're having a lot of fun just exploring how to use 2 to the 3rd, 2 to the 4th, 2 to the 5th. We got to see center points and their value. There's also 3 to the k out there. We'll take a look at that. And then finally, where this all is leading us to is model reduction. Today, we covered confounding, and in particular, we covered confounding between interactions and blocks. But as we get into model reduction, this confounding leads to an idea called aliases. And this becomes important for really all of these. The remainder of our work is confounding and using our interaction terms and aliasing them. But the goal here is model reduction. So that is the real strength of DOE. So in sum, you can see the way that these ideas build on each other, a lot of their relationship with each other, and the point of why we study each of these topics. This is just so you know, this is a concept map that's really in its infancy. I just kind of threw it together, and it has a lot more details to add, and maybe later on in the semester before the exams I'll share this because I think it helps us orient our knowledge.